Okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. So today, the date is December 11th. The time is 10:59 Eastern Standard Time. My name is Muhammad Faisal. We have with us Anas Khan. Mr. Anas Khan is going for his Diploma in Artificial Intelligence Operations exam, EduQual Level 6, RQF Level 6, which is equivalent to 360 credits. And essentially, after this, if he can pass the exam, he can apply for his master's degree, like in USA, Europe, UK, Germany, wherever he wants to go, in North America, in South America, I mean, in Japan, wherever he wants to go, he can go, inshallah. I wish you the best. Uh, my name is Mohammed Faisal. Today, we will be taking this exam. The topic is orchestration, uh, cognitive edge computing platform with neuromorphic processors, federated learning, and adaptive intelligence for autonomous systems. It has a lot of tongue twisters. Uh, some of these people who are sitting here don't even know what is neuromorphic computing is, right? If you ask a professor at a university, a CS professor, he might has to use a chat GPT to see what is that, what happens in there, let alone knowing what is happening in the industry, right? So our students are now going for all of these things while preparing for their exams. So that speaks volume of what we are teaching, right? So our job is to teach them the job description from day one. So there are certain key learning objectives: the neuromorphic computing and spiking neural networks, edge native federated learning, adaptive intelligence and continual learning, autonomous systems integration, energy efficient edge computing, distributed cognitive architecture, so on and so forth. This project challenges students. It's a challenge for the students to architect and implement a comprehensive cognitive edge computing platform. So you have to show me a design, data flow diagrams, network diagrams. How do you perceive the system to be? I'm not asking you to show me, how the system is running. If you want to do that, absolutely yes, you will get some extra marks for that. But I'm not going to deduct any marks for you if you're not able to show me, because as we move forward in 2026, this exam will disappear, the oral exam, right? So now students will then have to do these labs on the cloud that we have, right? Al-Nafi cloud. So we'll be talking about that. You have to show me computing platforms supporting neuromorphic processors, federated learning, and adaptive intelligence for autonomous systems and applications. The solution must enable real-time learning, energy-efficient computation, and distributed intelligence while supporting autonomous vehicles, robotics, and IoT systems. So this is what you have to show me. There are open source tools which I need to see. How do you propose or how do you envision to architect these things? For neuromorphic, it's Intel Lohi SDK, the SpinNaker Nest Simulator. By the way, in our Razak labs, these systems are already there, so you can use them and you can perform these labs. As part of the AI Ops, these labs will be given from January, February onwards, right? I've already seen these labs. Labs are already running, so on and so forth. So that's the next generation stuff that you'll be getting, inshallah. Federated learning, TensorFlow, Federation, PySoft, and Flower, Edge AI, robotics, optimization, edge computing, and standards. Specifically the raw standards, real-time operating system, for robotic process automation. For the presentation, you will be given minimum 15, maximum up to 20 minutes, followed by a Q&A session that is going to last from 30 to 40 minutes, right? The whole exam will be over within 45 to 60 minutes. Anas Khan, are you ready for your exam?
Yes, Faisal bhai.
Can you please share your screen?
Sure, I am going to share my screen. My screen is visible to you guys.
Yes, it is. Yes, it is. Okay. Bismillahir Rahmanir Rahim. You may start your exam now.
Okay, Bismillahirrahmanirrahim. Hello everyone, my name is Anas Khan. I am here to present the topic which is orchestrating cognitive edge computing platform with neuromorphic processes, federated learning and adaptive intelligence. In this presentation, I will be discussed thoroughly about federated learning, adaptive intelligence, what key role play these technologies and why these technologies are essential. Moving to the next slide. Here is the overview of my presentation, what will we cover in the next couple of slides. So without wasting any time, we are moving to the first slide. neuromorphic, com- Neuromorphic computing and agnative and spiky neural network. Before we deep dive into neuromorphic computing, first we need to understand what neuromorphic computing is. Neuromorphic computing is basically is a brain-inspired approach, hardware and software, which uses SNN spiky neural networks where neurons communicate through discrete electric pulses, which we call them spikes. They also use spike time independent plasticity. It's a bio-learning rule which adjusts the synaptic weights according to the timing of spikes, which enable efficiency in real-time learning for AGI and robotics. As you can see, guys, we have the architecture diagram of traditional von Neumann architecture. The second one is neuromorphic architecture. The traditional von Neumann architecture, guys, it depends on the binary inputs and process and provide us binary outputs. They needs continuous activation values in order to process the information. And when they needs continuous activation values, they need also continuous compute power, so which is not energy efficient. The second bottleneck is the memory and CPU is separate, so data is moving from the memory and CPU, which takes some time. So we are facing bandwidth issues. To overcome these issues, they designed the neuromorphic architecture. Neuromorphic architecture, rather than work on continuous activation values, they works on spikes. Information itself encoded in spikes. So spikes only used compute power when any spikes are event occur. If there is no spike occur, they will not use any compute power. So which is far more energy efficient, and memory and CPU is embedded within the neuron. So it reduces the bandwidth and latency issues as well. Moving to the next slide. Agnative federated learning. Agnative federated learning is a decentralized machine learning on the edge devices directly rather than transfer data to the centralized server. Each device model trains locally and only the model updates transfer. Improve overall efficiency and safeguard user privacy. What things we can achieve using agnative federated learning? We can enhance user data privacy protection, adherence, regulatory compliance, improve model accuracy, increase bandwidth efficiency, and greater scalability capacity. These are the key benefits we can achieve using agnative federated learning. Moving to the next slide. Here we have a architecture diagram of federated learning model. How federated learning model training works. As you can see, guys, we have in the diagram the edge compute center. The edge compute center acts as a global aggregator. What it does, it sends first broadcast model update to the all IoT devices for start their training. As you can see, guys, the each IoT device model has its own private data. So each IoT device model should be trained from their private data. They will not share any raw data with another IoT device model nor the edge compute center. What they do, they use their private data to train the model, and after training the model, all of those IoT devices send back to the model updates to the edge compute center in an encrypted way. And what does edge compute center? Edge compute center aggregates the model updates and send back to the model updates for enhanced and unified model updates for back all IoT devices for enhanced their learning. So that is how federated learning model training works. Moving to the next slide. What applications are using federated learning? Guys, as I mentioned in my previous slide, federated learning play a vital role because while training the model, it makes sure the end user data remain in the IoT devices. So that's why there are many critical applications are using federated learning like autonomous vehicles, digital healthcare, industry-based advertising, industries, personalizing smartphones, and bank fraud detection, and many other critical applications which are not included here, but they use federated learning. Moving to the next slide. Adaptive intelligence and continual learning. Adaptive intelligence is a capability of AI systems to adopt and improve as conditions or surrounding change. Continual learning enables systems to learn incrementally from new data while retaining existing knowledge, which help them to prevent catastrophic forgetting. Before I discuss the key points, I need to explain it to you guys uh, what a catastrophic forgetting is. Guys, I would say the catastrophic forgetting issue is not only face AI models because it's also face human as well. Because in many scenarios, guys, when we learn something new, so we are facing issue to forget our existing knowledge, existing some key points. So that's the same issue face AI models. When we train them with the new data, they forget their existing knowledge. They basically overwrite the existing data with the new data. That is called catastrophic forgetting. To avoid catastrophic forgetting, we are using multiple algorithms like elastic weight consolidation, reply buffer regularization, iteration techniques, reinforcement learning, to make sure our model should be able to learn continuously from the new data and make sure they retain their existing knowledge as well. And our model should be able to learn incrementally from small bunch of data set rather than they learn from huge bunch of data set from the initial stage. Moving to the key points, context awareness. Guys, I would say it is very essential our model should be able to context aware, because if our model not a context aware, so they will not behave according to the requirement. For instance, guys, if I give you an example, if we create a AI chatbot, and which chatbot is real-time integrated to our e-commerce websites, for instance. So if our model not a context aware, so what happened when end user interact to our AI chatbot and ask information about the steps which we are offering on the e-commerce websites. But for instance, guys, let's suppose if there is a guy who asks something else, or if their behavior is not good, they using abusive language, for instance. So if our model not context aware, they will not analyze the behavior of the person, they will not analyze the context of the person. So when they not analyze the behavior of the person, how is it possible, guys? Our model should be able to act and communicate effectively according to the requirement. That's why context awareness is very essential. Knowledge retention also very essential. As I mentioned earlier, our model should be able to retain existing knowledge when they learn with the new data. Incremental learning also very essential. Our model should be able to learn incrementally from the small bunch of data set rather than they learn from the huge bunch of data set from the initial stage. Dynamic adoption play a significant role because it helps significantly AI models to adopt new changes quickly and make decisions accordingly in a real time. Moving to the next slide. Here we have a comparison between static machine learning and adaptive machine learning. As you can see, guys, the static machine learning, it's a one-time process. We train our model, whatever the data we have, and then we live the model. That's it. Our model have only that knowledge which we provide them while training the model. For instance, guys, if I give you in a real world example, we are building the model for our company, a threat detection. And when we was building the model, we did not provide them any information about a DDoS attack. We did not provide them any logs. We did not provide them any traffic behavior, which type of traffic comes in when DDoS attack happens, so on and so forth. So simply our model have no idea, no knowledge about a DDoS attack. So what happened when we live the model, if in a real world scenario, if a DDoS attack happen, so our model is there, but they will not analyze the behavior of the traffic. They will not understand the traffic, is this traffic is legitimate or not. So when they not analyze the traffic, how is it possible, guys? Our model should be able to make decisions accordingly and stop the traffic. So that's why static machine learning model is not good. It is good, but it is good on that environment when you are not getting everyday new data. If you are running static machine learning model in a static environment, so that is perfectly fine. But the dynamic conditions, we have adaptive machine learning model. In the adaptive machine learning model, guys, we train our model and then we live the model. This model have ability to learn continuously from the new data which comes in from the multiple sources, either they are internet, they are logs, so on and so forth, which help them significantly to improve every day. So what happened when they see some new traffic or abnormal traffic with something suspicious, for instance, so they will far more better way from the static machine learning model to analyze the behavior of the traffic and make decisions accordingly, either should we stop the traffic or not. So in the dynamic conditions, we have adaptive machine learning model. That's the key difference between static machine learning and adaptive machine learning model. Moving to the next slide. Autonomous system integration. Autonomous system integration is about connecting multiple intelligent and self-operating systems such as robots, vehicles, and IoT devices into one coordinated network. Systems can share data with each other, communicate, and make collaborative decisions without any human intervention. Guys, I would say it is very essential. Our model should be able to make decisions wisely, rapidly, and independently without any human intervention, without any centralized server acknowledgement, which I will show you in the next slide with the example. What things we can achieve using autonomous system integration? We can achieve smart decision making, fault tolerant communication, collaborative coordination, and real-time synchronization. These are the key benefits we can achieve using autonomous system integrations. Moving to the next slide. Now the best slide comes in. Now imagine, guys, if your car could save your life when you can't drive. After watching this video, you guys will still clear about that, why I was saying in the previous slide, why it is essential our model should be able to make decisions wisely, rapidly, and independently without any human intervention, without any central server acknowledgement. So let's watch this video and then I will explain it to you after that. Okay. As you've seen in this video, guys, how autonomous model make wisely, rapidly, and independently decisions, how fast they take over the steering control, how fast they changing the track lines, how wisely they reduce the speed, and how wisely they make decisions to make emergency call in order to saving the human life. So that's why, guys, I was saying in the previous slide, it is very essential our model should be able to make decisions wisely, rapidly, and independently rather than they wait any centralized server acknowledgement or any human intervention. Because, guys, the autonomous models are working far away from centralized server, and if they are rely on human intervention, so there will be totally a nightmare, I would say. Moving to the next slide, energy efficient edge computing. Energy efficient edge computing should reduce power consumption in edge AI systems while still delivering strong performance. DVFS, dynamic voltage and frequency scaling, approximate computing, adaptive scheduling can significantly lower energy usage without any impact on performance. Before I discuss the key benefits, I need to explain it to you guys what dynamic voltage and frequency scaling is, because it's a new word maybe for you. DVFS, I would say it's the same concept of auto scaling, guys. As you already aware, with the Kubernetes, we are using horizontal pod auto scaling, vertical pod auto scaling, and in cloud we itself use auto scaling. So it's a simple terms, it's auto scaling, I would say. But we call them DVFS because multiple spikes are even happen to the autonomous model. So it extend the voltage and frequency to give them ability to handle and process the information. On the other hand, on the off-peak hours, if there is no spikes or even occur to the autonomous model, so it reduce the voltage and frequency to manage energy efficiently in a wisely way. That's the key role play dynamic voltage and frequency scaling. Moving to the key points, what things we can achieve, we can reduce latency, we can improve performance, lower bandwidth requirements, we can enhance security, increase reliability, and cost saving. These are the key benefits we can achieve using energy efficient edge computing. Moving to the next slide, distributed cognitive architecture. Distributed cognitive architecture is a decentralized machine learning framework that spread intelligence across its devices, nodes, and cloud resources. It helps them real-time decision making and collaborative learning for complex applications. Guys, I personally think the distributed cognitive behavior it's also mimics from the humans, because in many scenarios, guys, if I give you if I give you example, if a guy is sitting in a company and if there is any incident happen, so that guy is not only responsible for that incident to make decisions on it, because they have to collaborate with their colleagues, they have to collaborate with the senior management, they have to collaborate with the CTO in order to share the information and make decisions in a collaborative way rather than only one guy sitting there to make decisions on it. Basically, guys, we want a hierarchical intelligence. We did not rely on one person or one node, one AI model. So that's the same behavior used in autonomous system when any business critical operations are happen. So they use their AI models to process the information in a collaborative way and make decisions in a collaborative way rather than only one edge device to make decisions on it. Moving to the key points, hierarchical cognitive layers, because we have physical layer, edge layer, and the cloud layer, which I will show you in the next slide with the architecture. Dynamic task allocation play a significant role, I would say, because it helps us tremendously to allocate tasks dynamically based on resource availability, based on physical location, based on bandwidth requirements, and so on. Swarm-based coordination also play a vital role because it helps tremendously AI models to gather the behavior of the nature and make decisions accordingly in a real time. Context awareness processing also very essential, as I mentioned in my previous slide. It helps significantly AI models to behave according to the requirement. Moving to the next slide. Here we have architecture of edge computing. As you can see, guys, we have three layers: the device layer, edge layer, and the cloud layer. On the device layer, there are multiple IoT devices. Sensors are connected to the edge layer. Why they connected to the edge layer? Why they are not directly connected to the cloud layer? Because, guys, we specifically designed edge layer for our local AI inference. We did not want to 100% rely on cloud layer, and this edge layer help us significantly to reduce bandwidth issues, significantly help us latency issues, and where we are doing multiple things like data processing, data caching, control response, virtualization, and this edge layer is connected to the cloud layer. The edge layer, after containerized and compressed model updates, only the essential model updates sent to the cloud layer where the whole data resides in for the future model updates. The lane and when, I would say, it only depends on the architecture, I would say. For instance, if the device layer, edge layer is sitting on the same network, the communication should be local area network, and if they are sitting outside the network, the communication should be wide area network, as you guys are already aware with the lane and WAN architecture. Moving to the next slide, open source and cloud native tools. Guys, without open source tools, I don't think so we can implement a best solution, because open source tools are not only cost effective, they also provide us ability to customize the tool as much as we can according to our business need, according to our infrastructure requirement, and we can easily integrate open source tools with the multi-cloud architecture easily as compared to cloud native solutions. So that's why they are the backbone of modern cognitive edge ecosystems. What open source and cloud native tools we have for neuromorphic computing? We can use Interlohi SDK, SpinNaker, Nest Simulator. For federated learning, we can use TensorFlow federated, PySwift, and Flower. Edge AI inference, we can use on Excellent Time, OpenVINO. And for robotics integration and communication, we can use ROS2, Gazebo, and MoveAlt. For optimization, we can use Optuna and DApp. And edge computing, we can use CubeEdge, K3s, and EdgeX Foundry. These are the combination of open source tools which we are using for creating and running autonomous solutions. Moving to the next slide. Now, the architecture comparison between ROS and ROS2. Why ROS2 introduced, guys? What things are missing in ROS1 framework, so they introduced ROS2 framework. I don't have much time to elaborate each and every key enhancement in the ROS2 framework, but I will quickly show you 3 to 4 major enhancement in the ROS2 framework, and then I will wrap it up the whole presentation. As you can see, guys, the ROS1 and ROS2 framework depends on the 3 layers: the OS layer, middle layer, and the application layer. The first major enhancement in the ROS2 framework, as you can see, guys, the ROS1 framework supports OS layer only one operating system, which is Linux. But the ROS2 framework, multiple operating system, RTOS, real-time operating system. The second major enhancement in the middle layer, the ROS2, ROS1 framework's communication protocol supports ROS, TCP, and UDP, which is not far more efficient. But the ROS2 supports data distribution service, which we call them a DDS, which is far more superior, far more efficient, and able handle communication effectively without any issue. And it has built-in security. We can manage access with the context of role-based access control. It has built-in encryption and so on. The third major enhancement in the application layer, as you can see, guys, the ROS1 framework supports a master node, which you can call it's a single point of failure, because all of those communication happening on all the nodes from the within the master node. So if our master node goes down, all other nodes should be impacted. So it's a single point of failure as well. But in the ROS2 framework, they remove the master node concept, and each node individually responsible for make decisions on it. And if anything bad happened to the one node, they distribute the workload in another node. So they remove the single point of failure as well. These are the key enhancement missing in ROS1 framework. That's why they introduced ROS2. Moving to the next slide. Standard and compliance. Guys, without standard and compliance, I would say there will be a nightmare, because no matter what, if your solution is good enough itself, and even though it solves the end user problem, but ultimately end user reluctant to use them because they have security concerns, how your application, how your software handle end user private information. So that's why standard and compliance provide us clear guideline to help keep things consistent and secure. What standard and compliance we have? IE 2857, which gives us clear guideline to implement security on the neuromorphic edge architecture. ISO 26262 gives us clear guideline to implement security on the autonomous system, safety, and functional reliability. ROS standards, which gives us clear guideline to implement security on the robotics components, their integration and communication. Cloud native and edge compliance, which gives us clear guideline to how we can secure AI containerized workloads, which we will deploy on the edge architecture. The GDPR gives us clear guideline to how we can handle end user private information. So these are the standard and compliance which we need to make sure when we are creating any autonomous solution, so they are proper compliant with the relevant standards. Moving to the next slide. What's the challenges and mitigation? Guys, deploying cognitive edge platforms for autonomous system, we can face multiple challenges like hardware limitation, energy constraints, data privacy constraints, and system reliability issues. So effective strategies are needed in order to ensure our operations are running smoothly. For hardware limitation, we can use neuromorphic processors and model compression techniques to resolve these issues. Data privacy concerns, we can use differential privacy, secure aggregation, and homomorphic encryption to protect sensitive data. Energy constraints, we can use DVFS, and approximate computing can help us significantly to reduce unnecessary power usage. For system reliability issues, we can use continuous verification, hierarchical design, and intelligent task offloading can help us significantly to improve reliabilities. Moving to the conclusion, cognitive edge platforms with neuromorphic processes, federated learning, and adaptive intelligence are basically reshaping autonomous systems. They enable efficient real-time processing and continuous learning at the edge level, which supports scalable and reliable technologies. Moving to the key points: energy efficient neuromorphic processing, real-time autonomous decision-making, privacy-preserving federated learning, and adaptive and scalable cognitive system. These solutions, in a collaborative way, we can achieve a robust autonomous solution which able to work and think like human brain works. So that's all from my end, guys. Thank you very much, guys.
Okay, Bismillah Rahman Rahim. Who are the guys that you were referring to? कौन है guys यहाँ पर?
Guys, saying,
Okay, all right, okay. Bismillah Rahman Rahim. Good presentation, good flow, mashallah. You nailed it very well. Let's see how you do in your presentation, inshallah. In the Q&A. Okay. So explain to me, you lost some of the points because of the little bit of points, in your presentation because I need to see some more diagrams and stuff like that, right? But overall, it's very good. You secured 80, above 80% in your presentation, right? So let's see if you can do the same thing in your Q&A as well, okay? All right, so explain how a spiking neural network differ from traditional ANNs in terms of computation.
okay. Traditional ANNs depends on clock-based cycle. They needs continuous activation values in order to process the information. But the neuromorphic computing SNNs are the spiky neural network. The information is embedded within the neuron, so it only use the compute power when any spikes or event occur. So rather than the traditional ANNs, they use compute power continuously because they are clock-based cycle. So which is far more efficient and only use the compute power when any spikes are
So
event.
which one is good for static data and which one is good for mimicking the brain activity? Like if
Sorry?
I have to say that, which one's ANN between ANN and SNN, right? Which one is good for static data?
For for static data, I would say the ANN models is good.
Yes, good, mashallah. Okay, so ANNs are efficient for static data, right?
Yes, exactly.
And what about SNNs? What do they mimic?
They mimic like how brain works. Like our brain is not work like ANN models work like clock-based cycle, continuous activations. So our brain only use the power when any spikes occur. So they basically mimics like human brain works. So if any spikes occur, specific threshold occurs, so it only use the compute power at that time.
So good job, mashallah. So I'm going to ask you a question, which is very important, right? There's a lot of in the neuromorphic computing. There's a lot of work is being done. You showed a video of the car taking over, which is an example of. I have a car, Lexus RX 350 hybrid. It has the same feature when it looks into that if I'm driving and if I'm looking here and there, not at the road, right? So it says driver inattention detected, right? And it makes my steering a bit stiff, like it gives me a jolt, right? So pay attention on the road, right? When it happened the first time, I was paying it like I was like, what is happening? And then I realized, oh, this is the cars telling me, right? And if there's like an obstacle coming through, the car automatically puts brakes on it. It just says no, you know, there is some kind of obstacle, so it tries to protect itself, right? So more and more of these features are coming into these modern cars. When we talk about brain, right, a biological brain, can we say that the SNN, right, uh, the SNN has the spiking neural network? Can we say, is it safe to say that we can teach uh, SS, SNN, wisdom? I mean, how do you define wisdom? Right? So my question is like, the biological brain is a vastly complex entity, right? It uses spikes, learns via diverse plasticity, and combines raw processing, right, with wisdom. In today's world, what do you call wisdom when it comes to SNN? There's a word for that.
Specific words are coming in my mind, but I would say the reinforcement learning, continuous learning, they able to learn from the new data every day continuously, which
Okay.
help them significantly.
You already know the answer, I know. So I'm going to break it down further. When you're writing a prompt, right? What is the most important thing in the prompt?
Context.
Context. That's the thing. Okay. So remember that in all of these things, like this is a very crude terminology in a neuromorphic computing because I'm teaching these courses in our specialization, right? In the neuromorphic computing, context is sometimes called is known as wisdom. What is the question you are asking? It can be
Exactly.
a very ridiculous question. It can be a very good question, right? It can be an elaborative question. This is very important. So understand this in the LLMs and in all these mechanical things which are coming up nowadays, right? Uh, the context is the most important thing. So artificial neural networks and the spiking neural networks, the difference is context. The artificial neural networks is back propagation, efficient for large data sets. These are what LLMs are. This is what LLMs are, right? So they keep on gathering this kind of data. Their processing is fast for static tasks, example, image classification, voice recognition, stuff like that. They require high. I mean, the energy requirement is high, right? They consume a lot of energy and resources and whatnot. Spiking neural network. It works on what? What kind of data set does it work on?
What type of?
How do they work? How do they work? Jazakallah, just keep it here.
Sir, can you please rephrase
The
slightly?
the spiking neural network, SNN, right? How do they work?
Hmm.
I mean, when it comes to information, artificial neural networks requires continuous values, scalars. You know, that's how it learns. How does spiking neural network learns? What
Spiking
kind of
neural,
information does it need, first of all?
they may- they depends on spikes information itself encoded in spikes like spike timing and plasticity. So
Good. Okay, so yes, so they rely on discrete spikes, events over time, like real neurons do, right?
yes.
If I'm walking outside and something comes under my feet, a thorn or a rock or anything, I feel the pain, right? The brain already knows this is what happened, right? So I can imagine, so the brain can visualize, right, that something was there that hit me. When I go to Pakistan, my son, he complains about machar, mosquitoes, right? Because he says, yaar, machar bahut hain yahan par, right? I said, yes, these are well-trained mosquitoes. Like here in Canada, there are mosquitoes, but they don't bite you like that. So I said, these are Canadian mosquitoes. Or when you go to US, these are USA mosquitoes. Like apart from the Florida Everglades, there are some very nasty mosquitoes over there. But overall, you won't find something like that, right? But when we go to Pakistan, we can feel them spiking through, right? And you can feel them. This is spike neural networks. Once it builds the neuron, it knows. I used to when I have my kids, I used to teach them when my son was born. I was memorizing the Quran, right? So I read the whole Quran every day, like multiple juz, right? And while he was in my lap, right? मेरी गोद में था और मैं कुरान पढ़ता रहता था. Then he grew big. Then मैं इसको गोद में था, ठीक है ना, सो रहा है, बात कर रहा है, जो भी कर रहा है. And I'm reading, you know, multiple Islamic books, right? So he learned from me all the Islamic books. So when I used to ask him a question, he would answer. I said, you see, the brain cell is there. Because I've given you so much information in spiking neural networks that now your brain can process. So if you ask about, you know, Al-Bidaya wa Nihaya, the beginning and the end of Imam Ibn Kathir, he will be able to answer the questions because he has listened to me so many times, right? Asking the question again and again. So this is the cognitive level. So, but there is a problem. So what problems does spike timing dependent plasticity, STDP, solve in neuromorphic computing? What is the problem? What do we get?
First problem they solve, they remove the continuous compute power. They reduce power consumption. The second, they achieve the event driven, I would say, event driven. When any spike occur, any spikes are event occur, so at that time they use the compute power, so they save huge amount of energy.
Okay. So if I think about that, right? Where is the where is the learning happening? Is it happening? I mean, what kind of dependency does this remove? Like the STDP solve what in neuromorphic computing? What is the dependency that it resolves? This removes the dependency on back propagation. How?
Because the ANN models are uh, working clock based cycle.
No, no, no.
So
So you know the answer. So okay, so let's take a step back. I'm going to give you a hint. It's hardware, right? So
neuromorphic chips.
yes, the chips. So,
Chips.
this remove the dependency on the back propagation, looking at your slide, and enables on-chip learning.
On
On-chip
chip
learning.
learning.
You know, the Mac operating system has this M4 chip, right? If you go to Apple, right? Apple website, I'm going to show it to you. And they have something like this, right? You should read more about what is this thing, what is this thing, right? So go here. This is Apple website. Go to the Mac, right? And go to Mac Studio or Mac or MacBook Pro, whatever, right? So you can go to Mac Mini, whatever. They all have the M4, M3 architecture or the M4 architecture. When you go here, build for Apple Intelligence. What is that, right? So you go here, you will see something like this. If I select this one, it says M4 chips with 10 core CPU, 10 core GPU, and 16 core neural engine. What happens in this neural engine? This is the on chip.
Chip learning.
This is what happens. That's what it is. So there is a hardware dependency, and the hardware dependency is where like all the on-chip function happens, right? Okay. Next is you mentioned federated learning, right? Over centralized learning. Why? Why is federated learning over centralized learning is preferred?
Because in the centralized learning, the all IoT devices send the all of the raw data sent to the central server, so which is not good because the all IoT devices have private end user data. So the federated learning overcome this issue, and they make sure the end user private data remain in the IoT devices, and the model trained from their private data and sent to the encrypted model updates to the edge compute center. And edge compute center aggregates them using federated averaging, Fedflogs, and multiple other algorithms. So after aggregation, they send back to the model updates, unified model updates, sent back to the all of those IoT devices.
Okay. All right. Uh, Describe the difference between static ML and adaptive ML. In your diagram, you have to explain to me, but describe it to me.
Okay. In static machine learning model, we train our model from a fixed data set. So after training the model, we live the model. So our model, if we are running static machine learning model in a static environment, when we are not getting everyday new data, so that is perfectly fine because they are already trained with that data. But the adaptive machine learning model, but in the dynamic conditions, if we are running static machine learning model, so there will be a model drift, I would say. because they are not trained with the new data which comes in from the multiple sources, either they are internet, they are logs. So in the dynamic conditions, we have adaptive machine learning model which able to learn continuously from the new data which comes in from the multiple sources, either they are internet, they are logs, which tremendously help them to improve themselves every day. And when they see some new traffic, so they far more better way from the static machine learning model to analyze the behavior and make decisions accordingly in a real time.
In today's world, right? So we completed the first five easy questions. So the power round is over now, right? Five, six. Okay. This is where the fun part begins, right? So in today's network, in today's LLMs, right? In today's LLMs, are they using artificial neural networks or are they using spiking neural networks? I mean,
Mm,
ChatGPT, Claude, Gemini, DeepSeek, various other models from Huawei, from other companies. What are they doing?
they are not using spiky neural network, I would say, because spiky neural network only they are used on that environment where the end user IoT devices, when you are have critical end user private information, like if we are taking example of banks or hospitals. So in that environment where they have critical information, so in that scenarios you can use this model.
Very good, mashallah. I mean, if so tell me something about yourself.
about about my job.
No, no, no. So you did your metric, right? From Pakistan? 12th
Yes,
grade,
right
10th grade.
after
How old are you?
and right now I'm 27.
27. So when did you do your metric?
I guess 2017, around
2017? 2017. Okay. Yeah, it's
yes,
been 10 years. And then what were you doing then? This was the this is one of the difficult questions, right? And you were able to answer. So I just wanted to know your background. Before joining a NAFE, what were you doing?
Faisal bhai, before joining Al Nafe, I was doing odd jobs and waste my whole time. But after joining Al Nafe, first of all, when I joined Al Nafe, so I start my from CCST, and after learning
Level 3
CCST,
qualification.
yes, level
It's
3
equal into
qualification,
intermediate. You passed your exam, right?
yes,
What
right.
was your score in
So
level 3?
level 3 score, I didn't remember, but my grade is B,
B
grade
grade.
B.
Okay. All right. Today is not B grade, by the way. It's
Inshallah, inshallah.
mashallah, it's very good. It's coming out very good. That's why I wanted to ask you. Mashallah, it's coming out very good.
So
Um,
after
yeah, go ahead.
yes, so after learning from 6 to 7 months CCST, Alhamdulillah, I was secured a job as a junior server administrator. So when I was doing my job as a junior server administrator, I also enrolled in DevOps. So I was studying DevOps as well. So while learning DevOps, after 6 to 7 months, I secured a second job as an associate DevOps engineer. So I did work as an associate DevOps engineer 1 year, and after that, I switched in another company, which is right now I am here as a senior DevOps engineer. I am working right now.
Mashallah. So तुमने अपनी जर्नी स्टार्ट की when was that? When was that? कब?
2 years ago, I guess.
2 years ago. So first job तुम्हारी कब हुई थी? When was that?
First फर्स्ट जॉब मेरी आई गेस जब मैं स्टार्ट किया था कोर्स, उसके 3 4 माह बाद, एग्जैक्ट आई डोंट नो रिमेम्बर वेरी वेल.
So 3 to 4 months में, and so uh, this is very important, right? So you're answering me questions which are way tougher, and there are some more tougher questions are coming up. And I'm kind of surprised, mashallah, that a person whose qualification is metric, right? He came to us and he is now at that level that he's going for his level 6 exam. He did his level 3 and now you're going for level 6, right? Mashallah. Yeah, that's very good. Okay. That's amazing, mashallah. Okay. So let's go into something deeper, right? Does a hybrid, you know, okay, in a presentation. Okay, so does a hybrid neuromorphic federated learning architecture for autonomous vehicles, using the diagram that you have provided in your presentation, explain to me the details of how spike-based inference at edge nodes interacts with gradient-based updates in the cloud. How would they react with both of them?
First of all, can I refer my presentation?
Yes, yes, you can.
Which diagram are you referring?
Let me open this. Hold on. This one. What is this? You haven't graded your pages, right? Okay, hold on. This one, the तुमने slides पे number भी नहीं डाले. 13, page 13. I hope this is page 13. And I open this. Let me open this on the Word.
Mm.
This is the edge computing
Edge
architecture.
computing architecture.
Architecture.
Yes.
So in this architecture, right? Explain to me the hybrid, neuromorphic computing, right? Federated learning architecture for autonomous vehicles, right? For autonomous vehicles, using this diagram that you provided, detail to me how spike-based inference at edge nodes interact with gradient-based updates in the cloud. One thing we established, the spike neural networks work at the edge, right? Over there. They are sitting closer to the cars, right? They're much more
Right.
efficient, much more reliable. The ANNs are in the cloud, right?
Yes.
So what happens between them? Like, how does this, the spike-based inference at edge nodes interact with the gradient-based updates in the cloud? I mean, how does it collect the data? How does it send the data to the cloud?
Okay. So if
So
I
look at
have
the
to
middle
design,
layer. Look at the middle layer of how your middle layer is, right?
yes.
And explain to me how does the middle layer collects the data from the car, process it,
Okay.
send it over there.
Okay. That device layer, there are our autonomous vehicles or sensors which are generating raw data and sending to the edge layer where we are doing multiple things like data processing, data detection, caching, control response, and visualization, and process the model updates. And if anything, where we are doing local AI inference and send back to the our autonomous vehicle, and on only the essential model updates after quantized and compressed model update they send to the cloud layer where the our whole data resides in for the future model updates where the for future analytics, I would say.
Okay. Given the, edge cloud architecture, again, the same diagram, right? In the presentation, if, you know, you have to devise a failure scenario, so we have to devise a failure scenario. So the failure scenario is where the edge layer loses connectivity. How should the cognitive architecture adapt without compromising safety or autonomy? The person is driving the car, the edge layer, the cars are connected, right? The cars are connected to the edge. Someone hacked the edge, it took it down. Now what happens? Do I lose all the security? Do I lose all the safety features? Do I lose everything?
No.
What happens? What happens in the back end?
No, we will not lose all of those things because the our model on chips they working from the model updates which is last sync. So they work from the sync model updates which they are sync from the last time which they are connected to the edge layer. So when the connectivity resumes, so they back to the connected to the edge layer and collect all the model updates.
So where is the safety decisions data, is stored? Like, where is that logic is stored? How does it know I'm not connected to the mothership? I'm disconnected from the edge. How
If
does it make
our
a decision?
auto if our autonomous model lose connectivity from the edge layer, so the store data within the chips, so they use their learning which they got from the edge layer. So the the model updates stored in the chips which is on the autonomous vehicles. So when
So
the connectivity,
what is the international standard that calls for this thing? Advanced Driver Assistance Systems, ADAS, right? As they call it.
yes,
What do you call this ISO standard?
ISO 26262 for the
Yes.
autonomous safety and functional reliability to
So
implement
here's
strict
the thing.
validation control.
Here's the thing. Anas Khan, if you go and complete AI ops, inshallah, go to
Sure.
Germany, that's the birthplace of all the cars, right? Essentially. Not anymore, things are changing, but still, that's one of the biggest industrial places. The autonomous cars are everywhere, like in US, in all the places. And if you know how to work on ADAS, the autonomous, system, advanced driver uh, assistance systems, and if you know how to work on ISO 26262, because this is the same system they're using in cars, in trucks, in buses, in motorcycles, any vehicle that has electronics, you know, and electrical components needs to follow this safety system. You will never be jobless, right? If you add neuromorphic computing to it while you're driving and you are controlling, your brain is connected to the car, and if there is any temporal activity or something like that you're dozing off or something, it can be picked up by this, by basically by the lidar built into the car, but it also, and the camera and everything, but also other things as well. So think from that perspective, right? Inshallah, when you go out, because your goal is to go where, like from here, when you go to Canada or USA, wherever you want to go, inshallah, this is the industry that you should work in. One of the possible industries if you want to work in. Okay. All right. So let's jump in. This is where, let me show you. This is where your question came from, right? So तुम्हारा क्वेश्चन मैंने यहाँ से निकाला because this is part of your presentation, right? Okay. All right. So next in the presentation, two questions remaining. You come to Canada and there is a robotics fleet, right, in Canada. Uh, there's a company which is already working on that. All those driver jobs will soon go away because robotics is coming in, right? So an industrial robotics fleet is deployed in a warehouse. Each robot runs a neuromorphic processor for navigation and participates in federated learning for optimizing the pathways and everything, right? Suddenly, 20% of the robots began sending corrupted updates due to sensor degradation. Sensors, something wrong with the sensor, they're sending in corrupt data, right? How do you, as an architect, devise a recovery mechanism? कैसे करोगे? How would you do it? This is a job-based question.
Okay, if I am there as a AI engineer, so my first step would be the implement secure aggregation,
Okay, good,
homomorphic,
mashallah. Okay, secure aggregation.
ho-
Okay.
homomorphic encryption, anomaly detection,
Anomaly
to
detection. Okay, good,
is
mashallah.
to isolate the those data which is not good, I would say. And then if the some robots, if they are losing the connectivity of federated learning, use asynchronous updates so they can join from the next round.
Okay, that's good, mashallah. So tell me, the neuromorphic processor, you know, when will, in this case, will it switch to STDP, local learning, when the data is being corrupted from the sensors? What will happen? How the neuromorphic processors will switch? What would they do? And what would you do with those robots which are sending corrupted data? What would you do to them? Would you put them aside, I mean, what is the process that you will follow?
I will isolate them,
Isolate them, quarantine them, okay.
and then after blockchain authentication and robust aggregation, homomorphic encryption, I will create a unified model once again, and then send back to the send back to the robots.
Well, the thing is, like, you will neuromorphic processors switch to STDP only local learning while quarantined robots undergo recalibration, right? So you have to recalibrate the sensors, right?
Yes.
Recalibrate वापस करना पड़ेगा sensors को कि भाई क्या हो रहा है, what happened, what went wrong, right? Okay. All right, exam is over, mashallah. Okay, so 2, 5, 5. Okay. How was your exam?
Alhamdulillah, it was good, but
What is the but? Who's the but?
but I expect more.
You expect more? What is meant by more?
More means I expect more specific granular answers. I want to give you,
Yes, you have to give me some more granular answers. You're getting there, inshallah, like, right?
inshallah.
But exams are tough. Exams are not easy, right? So, but you did well, mashallah.
Because Faisal bhai, you have vast knowledge. So
It's not vast knowledge. I study, I work. The difference between, so there are two kinds of believer. Rasulullah Sallallahu Alaihi Wasallam said there's a two kinds of believer in front of Allah. One is a weak believer, one is a strong believer. Both, there is hasan in both of them. There's goodness in both of them. But Allah loves the strong believer more. You know why? Because he keeps on working hard. I am not like Imam Shafi, Maliki, Hanbali. They were the greatest scholars. I'm not like the companions. No one can be compared with them because their teachers was Rasulullah Sallallahu Alaihi Wasallam, right? We're just hardworking, nothing else. There's no secret. The secret is consistency. Someone asked me, how do you remain consistent, right? What do you do? So I showed them, when I start something, I stick to it. If it's memorization of Quran, I will stick to it. If I something, I will stick to it. So I showed them when I started Duolingo. Today is my 883-day streak. See that?
yes,
The streak. When I complete this, it will become 684 continuously. So when I do something, I will stick to it. If it's Salah, I tell my son, like, look, if it's time for Salah, when you hear the adhan हो गई, जाओ जल्दी से जाके नमाज पढ़ो, खड़े हो, जल्दी से खड़े हो, ठीक है ना? कोई भी काम करना हो, you have to be consistent. If you're not consistent, you will lose. I'm
indeed.
not special. I don't have any special talents. I just work hard and consistency. That's it. This is the see. If someone asks me what is the secret, this is the secret. For the past 21 years, I've been sleeping on time, waking up on time. Okay? So I will sleep at 10 and I will wake up at 4:30, 4:45. Whether it is Ramadan or it's not Ramadan, whether it's a vacation day or not vacation day, whether I'm in Pakistan or in Dubai, in Saudi, wherever I am, in UK, wherever I go in Canada, USA, this is my time, right? This is what it is. It's consistency. So it's not vast knowledge. Allah only has vast knowledge, right? I'm nothing.
Indeed.
But I work hard and I've developed this platform. And this is how I started this company when it was nothing. From one single desk, कराची में एक डेस्क थी, उस पे बैठे हुए थे लड़के, और मैंने वहां से पैसे लगाए, कंपनी स्टार्ट की. Now the company is about to become $1 billion company. 2017 में स्टार्ट की थी, 8 years हो गए, राइट? सही है. And where we are, this is where we are right now, right? So I wanted to disrupt the education. Alhamdulillah, I did it. I wanted to assist students to secure jobs. Alhamdulillah, we are here now, right? Okay, so I will ask you about all of that. MashaAllah, in your presentation, you secured 21 out of 25. This is 84%, okay? And in your uh, Q&A, you secured 20.5 out of 25, right? Which is 82%, okay? So the final presentation marks is 83%. If I add both of them, 21 plus 20.5, the final is basically coming out to be 83%, right? So
Alhamdulillah.
21 plus 20.5, that becomes 41.5 divided by 50. This is your score. MashaAllah, you have passed your exam. Okay? Now, Bismillah ar-Rahman ar-Rahim, this is what you need to do. जब तुम यहाँ आए, तुमने मैट्रिक किया हुआ था. What kind of jobs तुम क्या कर रहे थे? What kind of jobs were you doing?
फैसल भाई, जॉब्स और जॉब्स, मतलब कोई इस तरह के कोई जॉब्स कर नहीं रहा था, क्योंकि मेरे ऊपर कोई रिस्पॉन्सिबिलिटीज इस तरह की थी नहीं. मेरे वाले सब स्कूल टीचर हैं, तो
तुम घूमते
अल्हम्दुलिल्लाह
रहते
मैं,
थे, ऐसे ही घूमते फिरते रहते थे.
हाँ बस अपना टाइम. पर
उसको कराची में कुछ कहते हैं मटर गश्त करना. तुम मटर गश्त करते रहते.
पर जब मैंने अल्नाफे को ज्वाइन किया फैसल भाई, ऑनेस्टली कि अल्नाफे में ज्वाइन करने के बाद मेरा सारा कुछ चेंज हुआ. अल्हम्दुलिल्लाह मैं अभी एज अ सीनियर डेवऑप्स इंजीनियर जॉब कर रहा हूँ. जितना मैंने पे अल्नाफे पे किया, उससे बहुत ज़्यादा अभी तक मैं कमा चुका हूँ.
यार, लम्स से जीआईके से फास्ट से बच्चे निकलते हैं, उनकी लम्स और जीआईके में तो करोड़, 1.5 करोड़, 2 करोड़ लग जाता है. आईबीए से पढ़ के निकलते हैं, जॉब्स नहीं होती. एनईडी से पढ़ के निकलते हैं, कराची यूनिवर्सिटी से पढ़ के निकलते हैं. सारी बड़ी बड़े नाम है. द प्रॉब्लम इज दे टीच यू नो हैंड्स ऑन. दे गिव यू अ डिग्री, अ पीस ऑफ पेपर, सब कुछ. लड़के जाके इधर उधर घूम रहे होते हैं, राइट?
एंड
जब उनको पता चलता है कि यार जॉब कैसे करनी है, बहुत सारे फंकार बैठे हुए हैं फेसबुक पे, इधर उधर सब जगह. वो उनको फ्रीलांसिंग में इधर उधर उल्टी सीधी जगहों पे लगा लेते हैं. तुमने
फैसल
यहाँ आए,
भाई,
तुमने लेवल 3 ख़त्म किया, तुम्हारी फर्स्ट जॉब हो गई. तुमने लेवल 4 पढ़ना शुरू किया, फिर लेवल 6 में तुम आ गए. अब तुम्हारे बेस्ट इंटर भी कर लिया, लेवल 3. मैट्रिक के बाद तुम्हारी इंटर क्वालिफिकेशन हो गई. लेवल 4 भी तुमने कर लिया, राइट? अब तुम क्या करना चाहते हो? व्हाट डू यू वांट टू डू? क्योंकि देखो, ये चीज़ें तुम कर चुके हो. इफ आई शो इट टू यू, दिस इज व्हाट यू हैव डन, राइट? ये चीज़ें तुम कर चुके हो, राइट? ये जो है ना, क्वालिफिकेशंस हैं. हमने जो स्टैंडर्ड जो बनाया ना, वो हम इसके हिसाब से चलते हैं. RQF, राइट? SCQF और RQF, इनके, ठीक है ना? तो तुमने लेवल 3 कर लिया, DCCS तुम्हारी जॉब हो गई. तुमने लेवल 4, 5, 6 पढ़ लिया. अब तुमने ये भी पास कर लिया, माशाल्लाह, राइट? सो यू हैव पास्ड ऑल ऑफ दोस थिंग्स. व्हाट डू यू वांट टू डू नाउ? अब क्या, कहाँ जाना है? तुम्हारी जॉब भी हो गई, पैसे भी कमा रहे हो. और क्या 6 फिगर सैलरी कितनी है?
यस फैसल भाई, अबव 6 फिगर,
तो
अबव वन
अच्छी बात है.
हंड्रेड
कितनी?
यस, अबव 100,
माशाल्लाह,
वन
गुड.
हंड्रेड के.
तुम खुश हो यहाँ कराची में रह रहे हो अभी? तुम्हारे घर वाले कहाँ हैं? वो सब आज़ाद कश्मीर में किधर है?
हाँ, वो सब आज़ाद कश्मीर में. वालद साहब इस दफ़ा सर्दियों में आए हुए हैं, क्योंकि आज़ाद कश्मीर में बहुत सर्दी होती है, तो वो इधर मेरे पास ही रह रहे हैं अभी.
अच्छा, चलो, अच्छी बात है, माशाल्लाह. गुड. अभी तुम कहाँ, ऑफिस में बैठे हो?
जी जी, ऑफिस में हूँ अभी मैं,
ठीक है.
क्योंकि यहाँ पे इंटरनेट का इशू आ जाता है ना घर पे, तो इस वजह से फिर.
सही है, अच्छी बात है, अच्छी बात है. अल्लाह ताला तुम्हें कामयाबी अता फरमाए. देखो, दिस इज माय रिकमेंडेशन फॉर यू. ओके, बिकम अ क्यूबी एस्ट्रोनॉट. ठीक है. सैयद
यस
अबाबुर रहमान 16 साल का बच्चा है, वो जा रहा है बाहर मास्टर्स करने के लिए. जुनेद पंजाब से है, वो जा रहा है मास्टर्स करने के लिए. मल्टीपल लड़के यूके मास्टर्स करने निकल गए हैं, यूएसए चले गए हैं, जर्मनी चले गए हैं. ठीक है ना, कनाडा आ रहे हैं. ठीक है, ऑस्ट्रेलिया भी जा रहे हैं. ठीक है, न्यूजीलैंड, जापान. मैं किसी को भेजना चाहता हूँ यार, जापान जाओ. ठीक है ना, मुसलमान बहुत ज़्यादा हैं वहाँ पर, फैल रहे हैं, सब कुछ है. हमें जापानी बीवी मिल सकती है. ठीक है ना. तो मेड इन जापान गाड़ी भी अच्छी है, मेड इन जापान बीवी भी ज़बरदस्त है. ठीक है ना. तो मैं एक दोस्त को जानता हूँ, उसने जाके वहाँ पर शादी की है, ठीक है। और बड़ा खुश है माशाल्लाह, ठीक है। बट ही इज़ फ्रॉम यूके, वो यूके से है, उधर गया, ठीक है ना। इंडोनेशिया जा सकते हो, मलेशिया जा सकते हो, दुनिया तुम्हारे लिए खुली हुई है। जो पढ़ा लिखा आदमी होता है ना, जिसके पास स्किल्स हो और पढ़ाई हो, तो वो जाके सब जगह काम कर सकता है। बाहर एक मसला है, लोग समझते हैं जर्मनी चला जाऊंगा काम हो जाएगा। फ्री में एजुकेशन दे रहे हैं, फ्री में तुम्हें तो दे रहे हैं, वो गवर्नमेंट से पैसे ले लेते हैं, लेकिन तुम उसको कागज को पकड़ने के बाद तुम्हें जॉब नहीं मिलेगी, ठीक है। जॉब मिलती है जब तुम्हें जॉब डिस्क्रिप्शन पढ़ाया जाए। हम तुम्हें वो कागज भी दे रहे हैं जो तुम्हें चाहिए, और तुम्हें जॉब डिस्क्रिप्शन भी पढ़ाना है, इसलिए तो तुम्हारी जॉब हो जाती है। कोई खास कमाल है इसमें कोई?
असल भाई एक चीज़ ऐड करना चाहूँगा कि मतलब नाफे से पढ़ने के बाद मैं यहाँ जिस कंपनी में अभी जॉब कर रहा हूँ, इससे प्रीवियस कंपनीज में मतलब मेरे साथ 14-15 ईयर्स ऑफ एक्सपीरियंस वाले बंदे भी बैठे होते हैं, लेकिन अल्हम्दुलिल्लाह मतलब जितनी नॉलेज, वास्ट नॉलेज, मल्टीपल थिंग्स, सिक्योरिटी, जीआरसी, क्लाउड, डिवीजन, एवरीथिंग, ऑल ऑफ दोज थिंग्स, मतलब इतना एक्सपीरियंस उनके पास नहीं होता जितनी नॉलेज अल्हम्दुलिल्लाह मेरे पास होती है,
ये
मतलब।
बहुत है, बहुत। जैसे यू नो, इमाम अद्दहबी की किताब है, पूरा इंसाइक्लोपीडिया है, ठीक है ना। अगर इंसान पढ़े बैठकर, मैं आजकल पढ़ रहा हूँ, ठीक है ना। तो जो हमारी इस्लामिक एकेडमी शुरू होने वाली है, उसमें मैं उसके कोर्सेज डिलीवर कर रहा हूँ। लाइफ ऑफ ऑल द कंपेनियंस, जितने भी जितने भी सहाबा कराम आए हैं, ठीक है ना। और मैं बहुत सारी इसके ऊपर चीज़ें लिख रहा हूँ, कर रहा हूँ, ठीक है ना। पढ़ते रहना है। अगर तुमने रुक गए और तुमने काम सीखते रहना है, अगर तुम नहीं किया तो तुम रुक जाओगे। एक लड़के की कॉल आई मेरे पास, ठीक है। और इसका नाम हारिस है, ये यूएस में काम कर रहा है, ठीक है। और इसने ये मेरे पास आया, इसने कहा फैसल भाई, जो है ना, मैं एमबीए करने का सोच रहा हूँ, ठीक है। और आप जो है ना मुझे बताएं कि मुझे क्या करना है। जॉब वॉब हुई भी इसकी, यूएसए में काम कर रहा है ये, ठीक है। पहले यूएस नेवी में था, मैंने कहा यूएस नेवी में काम करना सही नहीं है, छोड़ दो इसको, ठीक है ना। तो एनीवे, इससे मेरी बात हुई तो देखो इसको, इसने कहा कि मैं ना मैनेजमेंट में जाना चाहता हूँ, और मुझे ना मैनेजमेंट में जॉब करनी है एज अ डायरेक्टर, तो मैं एमबीए करूंगा तो बहुत फ़ायदा हो जाएगा। तो इसको देखो मैंने क्या इसका जवाब क्या दिया। वालेकुम सलाम रहमतुल्लाहि व बरकातहू। एमबीए की जीरो वैल्यू है, जीरो। देखो तुम एज अ मुस्लिम दाढ़ी वाले आदमी सब कुछ ठीक है ना, तुम्हें टेक्निकली और मैनेजरियली अगर अपने आप को साउंड करना है, जितने प्रोजेक्ट्स मैंने तुमको बताए हैं, तुम्हें वो बड़े बड़े प्रोजेक्ट्स कंपनी में जाके करने होंगे। तुम्हें कंपनी के पेन पॉइंट इश्यूज को देखकर मैनेजमेंट को आगे जाकर परसू करना पड़ेगा कि ये मैं प्लान लेकर आया हूँ, इससे हमारे इश्यूज सारे सॉल्व हो सकते हैं। दिस इज हाउ यू बिकम बेसिकली अ मैनेजर, अ डायरेक्टर। एट द एज ऑफ 30, 28, 27, sorry, 27, I was already a director, a senior director actually, not a director, but a senior director. By the age of 30, I was already a CISO. 29 में ही मैं CISO बन चुका था, ठीक है। फिर CIO बना, उसके बाद फिर CTO बना, फिर CIO बना। द पॉइंट इज कि तुम्हारे जो प्रोग्रेशन पाथ है वो वही है जिस तरह मेरा है, ठीक है ना। टेक्निकली इन बिजनेस साउंड, यानी कि बिजनेस और टेक्निकल जार्गन्स में साउंड होने के लिए, तमाम चीज़ों के लिए तुम्हें प्रोजेक्ट्स करने पड़ेंगे। तुम्हारे पास अब काम आसान है, बिकॉज अब तुम एआई की इम्प्लीमेंटेशन करके बहुत सारे प्रोजेक्ट्स को डिप्लॉय कर सकते हो। तुमको मैंने बहुत दफा कहा लैब्स करो, लैब्स करो, लैब्स करो, तुम सब लोग शॉर्टकट ढूंढते हो, दो तीन चार चीजें करते हो, जॉब्स हो जाती हैं, उसके बाद जो है ना आगे निकल जाते हो, बोलते बस छोड़ दिया। इस तरह नहीं होता हारिस, तुमको मैंने बहुत दफा समझाया है, बट यू डू नॉट लिसन। जाओ, अगर करना है यू कैन डू दैट, ठीक है ना, बट दैट्स नॉट गोइंग टू हेल्प यू आउट। सो ये तुम्हारे लिए भी है, जितने लोग यहाँ बैठ के सुन रहे हैं इन सब के लिए है। अगर उनको काम करना है, दे हैव टू अंडरस्टैंड वन थिंग, कि तुमने अपनी पढ़ाई नहीं रोकनी है। तुमने कर लिया ना, अब रजाक कंप्लीट करो, उसमें सारी लिनक्स की लैब्स हैं, सारी लिनक्स की कैटलॉग है, क्यूबरनेटीज, क्यूबी एस्ट्रोनॉट, गोल्डन क्यूबी एस्ट्रोनॉट, टोगैफ है उसमें। तुम्हें पता भी नहीं टोगैफ क्या है। इसी डेवऑप्स इंजीनियर से पूछो टोगैफ क्या है, बोलेगा टोगैफ क्या है, टॉफी का नाम है क्या है ये? बोलेगे क्या चीज़ है यार, तो चॉकलेट है क्या है, ठीक है ना। तो बहुत सारी चीज़ें हैं इसके अंदर, पहले वो ख़त्म करो। जब वो ख़त्म हो जाए, जॉब में और ऊपर आगे जाओ। सेटल हो गए, 1.5 2 लाख, 2.5 लाख, 3 लाख पे चले गए, अब उसके बाद स्पेशलाइजेशन करो मजीद। इन द मीन टाइम पैसे भी जमा करो अपने लिए, ठीक है, सब कुछ करो। और उसके बाद फिर तुम जाओ बाहर मास्टर्स करने के लिए। कनाडा आ सकते हो, यूएसए जा सकते हो, ऑस्ट्रेलिया जा सकते हो, इवन जापान जा सकते हो, ऑल ऑफ
अच्छा।
दीज कंट्रीज आर अवेलेबल। जर्मनी जा सकते हो, ठीक है ना। सब जगहों पे तुम जाके काम कर सकते हो। एक फायदा है, उसकी वजह यह है कि दुनिया में जितनी एआई की जो लाइब्रेरीज हैं, किस जबान में है? इंग्लिश में।
इंग्लिश।
तमाम एसडीकेस किस जबान में है? इंग्लिश में। तो अगर चाइनीज काम करे या फ्रेंच काम करे, सबको काम करना उसी जबान पे है। इंग्लिश सीखना जरूरी है, ठीक है। तो उसके लिए तुम्हारे पास सारे गेटवेज खुल जाते हैं। हाँ, कुछ कंट्रीज में तुम्हें, अगर जापान जाते हो तुम्हें सब मिल जाता है, तो तुम्हें जापानी जबान सीखनी पड़ेगी, सीख लोगे, ठीक है ना, कोई मसला नहीं। जर्मनी जाओगे, जर्मन जबान सीख लोगे, ठीक है ना। हर चीज कर लोगे। वो तुमसे बेसिक चीजें मांग रहे हैं, सब कुछ करना है, लेकिन तुम कर लोगे। बट यू विल बी एबल टू डू इट इंशाल्लाह, बट यू हैव टू फॉलो द पाथवे। इफ यू फॉलो द पाथवे,
इंशाल्लाह।
यू विल बी सक्सेसफुल इंशाल्लाह। ओके,
इंशाल्लाह।
दैट्स व्हाट यू वांट टू
फैसल
डू।
भाई,
यस, गो अहेड।
फैसल भाई आपका फ़ोन नंबर मेरे पास सेव है, मैसेज करूँ आप सेव कर लेंगे मेरा नंबर कभी
हाँ हाँ, अभी चलो करो, मैं
आपसे?
सेव करो, चलो बिस्मिल्लाह, इट्स इन फ्रंट ऑफ मी, बताओ।
ये
अनस
अभी मैंने
खान।
मैसेज किया, सेव हुआ है आपको?
जी जी, मैं लिख रहा हूँ, सेव करो।
थैंक यू फैसल भाई।
क्रिएट न्यू कॉन्टैक्ट। ठीक है, इंशाल्लाह मैंने कर दिया तुम्हारा। लिख दिया है, अनस खान ए आई ऑप्स 83% पास्ट, ठीक है ना। तो मुझे याद
ठीक है फैसल।
रहेगा, ठीक है, चलो। जज़ाकल्लाह खैर।
ठीक है फैसल।
वालिदैन को सबको
जज़ाकल्लाह।
दुआओं की दरख्वास्त है। अल्लाह ताला तुम्हें कामयाबी अता फरमाए, और अपनी जर्नी मत रोकना। कीप ऑन मूविंग फॉरवर्ड इंशाल्लाह। लुक इनटू द कोर इंटीग्रेशन डोमेन्स, कि तुम्हें किस डोमेन में जाना चाहिए। अगर तुम मजीद एआई ऑप्स के अंदर डीपर जाना चाहते हो, तुम जा सकते हो, काम कर सकते हो। यू जस्ट हैव टू ऑर्गेनाइज योरसेल्फ इंशाल्लाह। बी कंसिस्टेंट। कंसिस्टेंसी इज द की, राइट,
ठीक है।
इंशाल्लाह। चलो,
थैंक यू
खुसूसी
फैसल भाई।
दुआ की दरख्वास्त है वालिद से, वालदा सबसे, ठीक है ना। वालदा जिंदा है ना तुम्हारी?
जी जी, हयात है।
ठीक है, बस दुआओं की उनसे दरख्वास्त है। सुब्हानक अल्लाहुम्मा बिहम्दिका, अशहदु अल्ला इलाहा इल्ला अंता, अस्तगफिरुका व अतूबु इलैक।